Hello everyone and welcome back to this channel. Let's evaluate the limit as x approaches infinity of through x minus ln of e to the x minus 2. First observe that as x approaches infinity through x goes to infinity, ln of e to the x minus 2 goes to infinity, implying that minus ln of e to the x minus 2 goes to negative infinity. So we have an indeterminate form infinity minus infinity. Here inside the natural logarithm, we're gonna factor out e to the x. The limit becomes now let's use the log identity to transform this expression. Heads up before this. If a and b are real numbers not equal to 0 and their product is strictly positive, then the natural logarithm of the product of a and b is equal to the sum of the natural logarithms of the absolute values of a and b. For example, here we use absolute values to make sure we are taking logs of positive numbers only. But if we already know that a and b are both strictly positive, then we can write ln of the product of a and b is equal to ln a plus ln b. Applying that, the limit becomes here as x approaches infinity, e to the x is strictly positive and 1 minus 2 over e to the x is strictly positive. Since both expressions are strictly positive as x approaches infinity, we can remove the absolute values. The limit becomes ln of e to the x is equal to x. Now let's evaluate these two expressions separately. As x approaches infinity, 2x goes to infinity. As x approaches infinity, 2 over e to the x goes to 0. So we have here 1 minus 0, that's going to give me 1, implying that the limit as x approaches infinity of ln of 1 minus 2 over e to the x is equal to ln of 1, which is equal to 0. Here, as x approaches infinity, 2x goes to infinity and ln of 1 minus 2 over e to the x goes to 0. So here the limit is equal to infinity. Finally, we can write